Hi, I'm Andrew. For my Insight project, I consulted for a company to develop a model for detecting anomalous water flow activity. The number one cause of property damage in the US is due to water leaks, accounting for over $10 billion annually. Even small leaks can be extremely wasteful. Aquaseca, the company I consulted for's solution is to use acoustic sensors to monitor the water flow. These are very non-intrusive sensors that sit on the outside of water pipes. So my task was to develop a model that would identify any anomalous activity. This could be water leaks or maybe prolonged consumption. Then they could send this information to their customers. The data is very low-level acoustic sensor data. So the signal is broken into different frequency bands by performing a power spectral density, and then I have the power reading from each of these individual bands. So this is time series data, and a single event is a 1-second readout. So the sensor will listen, and if the signal is interesting above some background noise threshold, then it'll record for 1 second. So there are 2 sensors per environment and 2 different environments used, either a commercial or residential setting. So this plot here shows the 2 sensors from a commercial setting, and this is from one of the individual frequency bands. And we see that both of the sensors, even though it's the same environment, they do look very different. So I analyzed 10,000 events per day, coming from about 3 months of data. And this really does call for an unsupervised approach. We don't have any labels to know if something was anomalous or not. So the task really was to use these kind of few and low-level features and maximize the event information. So the first thing I did was aggregate the events. So if there was some kind of really interesting signal, the sensor reads for 1 second, but you might get a sequence of these 1-second events, say 60 events in 1 minute. So I would aggregate all these together into a single event. And then I would also filter based on this information as well. Oftentimes the sensor would activate, record for 1 second, and then deactivate. Say if these kind of check events happened in 3 minutes or less, then I would just discard them from the data set. I incorporated some temporal information by looking at the hour and the day. So we might think that the water usage might look different, overnight versus during the day, and also maybe on the weekend versus during the working week. Since this is time series data, I built in some event latency by saving the power information from the previous few events into the current event. And in general, the sensors are not correlated. So if they did go off at the same time, I accounted for that as well. So all of this was fed into a model. I tried a few different models and settled on isolation forest. I found that these met the client's needs for production, but also were extremely efficient and performed very well. So here is about 1 month of data. So each vertical reading is the individual power readings from each of the individual frequency bands. And what the model is detecting here in red are the different anomalies. In general, it's getting these very large peaks. This is log scale, and also these power shifts. So really what this model has given us is some kind of baseline to build on to detect, potential leaks that might be very high power or any usage that might happen for a very long time. And indeed, that's what I found, that anomalies tended to have these longer readout times and also higher total power. So on the previous plot, this is the total power from all the frequency bands. And we can see how the model is separating the anomalies from the nominal activity, and the anomalies tend to be higher. So isolation forests were very good for the needs for production. In particular, they had very little assumptions, so there weren't really any hyperparameters to tune. So I delivered this to the client, and we're currently working on doing production tests. So my background is in experimental particle physics. I worked at CERN, a laboratory in Switzerland, for about 2 years. I analyzed a very large data set where I performed simulations and used high-performance computing to search for a rare signal. I was specifically looking for evidence of extra dimensions in the universe, and I enjoyed my time living, working, and traveling overseas. Thank you.